Good morning, everyone. My project is sentiment analysis on Yelp reviews. These are the contents that I'll be going through in my presentation. So previously, my dataset was SST2, and it was based on a pen tree bank format, because of which I decided to change the dataset into Yelp reviews. So I'll just give these are the objectives. My objective is to perform sentiment analysis on the Yelp review dataset using the binary classification for positive and negative sentiments. I've used two different vectorizers to vectorize the data, that is TF-IDF and Word2Vec, and I've used Logistic Regression Model separately on two different vectorized data. And then I've also used DistilBERT. Evaluated the models using metrics such as accuracy and confusion matrix, and compared the results. So a brief dataset overview. The Yelp reviews dataset, it consists of customer reviews based on different types of businesses like restaurants, hotels, and services. And it is widely used for sentiment analysis due to its richness in content and diversity. It also provides a real-world representation as it is real-time data. Yelp is an application based in America, so they have this application where we have all the reviews. This is a very huge data set. So for that, I created a subset of first 5,000 reviews, and it has a separate column with stars, and the stars range from 1 to 5. So what I've done is, for positive statements, I've taken stars greater than or equal to 4, and for negative, I've taken less than or equal to 2, and the stars that contained like 3 stars, I've excluded them from my data as they were neutral sentiments, because I'm mainly working on positive and negative sentiment for binary classification. This is my workflow. Firstly, I pre-processed the data, cleaned the data by removing the special characters, converted to lowercase, and eliminated stop words. Then vectorized using TF-IDF and Word2Vec vectorizers separately. And then I trained logistic regression on TF-IDF vectorized data as well as Word2Vec vectorized data in order to understand how differently the results are, like how the accuracy changes based on the type of vectorization. And I've also trained DistilBERT model and evaluated based on accuracy and confusion matrices. These are the results. The accuracy for logistic regression of TF-IDF was 89.11, and for Word2Vec was 91.404, and DistilBERT was 93.53. These are the confusion matrices. The main challenges and limitations that I faced was class imbalance, as the negative sentiment was very less, as I've already taken only first 5,000 reviews in the data set. So the negative sentiments were around 900 something, and the positive sentiments were close to 3,000. So because of the class imbalance, I felt like that was a challenge, and that's how it affected the accuracy and the confusion matrices as well. And this is the conclusion. I'll proceed by showing the code. So I loaded the dataset. This is the dataset. It contains stars, text, and labels. It does not contain labels actually, like I showed in the data preparation process. I have assigned the labels based on the stars. So this is the subset, first 5,000 reviews. Here are the libraries that I've imported in order to perform pre-processing on the dataset. That is regular expression, NLTK, and I've imported stop words, word tokenize, and WordNet lematizer for lemmatizing the dataset. I've initialized the lematizer, WordNet lematizer as lematizer, and this is my pre-processing function. Firstly, I've converted the text to lowercase and removed special characters by using the regular expression, and tokenized them using word tokenize, and then removed the stop words, and proceeded with lemmatizing the text. And then I've applied the preprocessing function to the text data in my file. So here we can see that it has preprocessed my text and has given a list of strings. So I proceeded with selecting specific columns that I needed to perform the further analysis, that is label and text, and saved it into a different file in order to use it for the for training the model. I've imported TF-IDF vectorizer from sklearn library, and train test split to split the data, logistic regression to train the logistic regression model, and classification report and accuracy score to evaluate the model. I've loaded the data set here and defined the features and mapped positive to 1 and negative to 0, and split the data in 80-20 percentile. And here in this, I'm using TF-IDF as vectorizer with max features as 2000, and I've vectorized the train and test data. Here I've trained my model, logistic regression, and then I made predictions using this. Here I've evaluated the model's accuracy and classification report, and this is the accuracy that I got for the TF-IDF vectorized data for logistic regression model. And I've plotted a confusion matrix. This is the confusion matrix for this this particular model. Then I used Word2Vec as a vectorizer, and firstly I've imported Word2Vec from Gensim library and NumPy to perform. Since the text is represented as a list of strings, I had to convert it into the actual string. So I converted it here by using this code. Then trained a Word2Vec model, and I adjusted these parameters in order to get a better accuracy. This is the function to convert the sentences into vectors. After creating, I've used this function on this this tokenized text that I've changed into list. I've used it and converted into sentence vectors and updated this sentence vectors in a new data frame. Then got this got X and Y features from this updated data frame. Then split the data, and then I've trained the model. And this is the accuracy of logistic regression on Word2Vec vectorized data, and this is the confusion matrix. So I proceeded then with DistilBERT. Firstly, I installed all the necessary libraries and loaded the data set. Then defined the features and mapped the label positive to 1 and negative to 0, and split the data set. Tokenized using DistilBERT tokenizer fast. And then I got this train encodings and test encodings by using this tokenizer. And then I used Torch, that is PyTorch, for creating this dataset objects from the encoded data. We can also use TensorFlow, but I prefer using PyTorch in order to change the encodings to dataset objects. And then we use these we use this dataset objects for DistilBERT sequence classification. As I'm performing sentiment analysis, we use sequence classification, and here I've imported DistilBERT for sequence classification trainer and training arguments. These are the training arguments. This is the output directory, learning rate, epochs, and train batch size, evaluation batch size, warm-up steps, weight decay, logging directory, and logging steps. Here I called the model DistilBERT for sequence classification, and then I trained. Here the model is DistilBERT for sequence classification. Arguments are training arguments that I've given here. Train dataset is this one, the data objects, and eval dataset is the test dataset. And then I trained using the trainer for 2 epochs. Then evaluated the model. I got this eval loss, and then plotted a confusion matrix. This is the confusion matrix, and this is the accuracy that I got for DistilBERT. Yeah, 93.53.